Particle evolution is real. Since school, we are told a simple story: an electron is an electron. A proton is a proton, and their properties are the same everywhere for all time. In energy filament theory, this picture has to go. Particles are not fixed mechanical parts. They are dynamic patterns held up by the local energy C. When the tension of that C changes, the pattern and its properties quietly change with it. Take the electron dot in this theory. It is a clean little filament ring with an internal loop rhythm and an outward straight texture that shows up as negative charge. It can only live in that form if it sits inside a stability window set by the local environment. How tight the C is, how dense the texture is, and how fast rhythms are allowed to run all decide how tightly the ring wraps, how fast its loop cycles, and how the surrounding energy levels line up. In a region with higher tension, the same filament would be squeezed harder. Its loop rhythm slows, its texture gets denser, its level spacing changes. In a region with lower tension, the ring relaxes, the rhythm speeds up, the spacing shifts again. So an electron in the early universe and an electron here and now are not literally the same internal structure. We just give them the same name. Then why do our experiments keep saying electron mass is constant, spectral lines are constant, level spacing is constant? Because your instruments are built from the same stuff. The electrons, protons, and atoms in your detector live in the same local tension as the electrons you test. When local tension changes, the test particle changes and your measuring clock changes with it. You are using one rewritten rhythm meter to measure another rewritten rhythm meter, so the ratio looks unchanged. In that sense, particle properties are locally normalized values. Purely local experiments cannot see the evolution. So where do we see it? In light. When an electron jumps between levels, it hands the rhythm difference between those levels to the energy C as a disturbance wave packet that is what we call light. That packet carries how electrons were beating right there, at that time. And it keeps that beat as it travels. When the light reaches us, we read it using electrons tuned to today's local tension. The old beat and the new beat do not match. That mismatch is what we call redshift. The light is not being stretched on the way. We are comparing yesterday's electron rhythm, frozen into the light, with today's electron rhythm, built into our instruments. Of course, it looks redder and slower. Next episode, particle time fingerprints. Tap follow, share it on New Physics, Clear Universe.